This is part of the series on advanced spring design from the Universal Technical Systems and the Spring Manufacturers Institute. This particular session will be on new features for compression springs, in particular compression springs that are cylindrical and round wire. The three issues that we'll cover will be auto adjust inactive coils, that option, the user-defined SN data option, and the minimum weight spring design option. The auto adjust inactive coils option is now the default when this spring type is loaded. What it has to do with is the fact that for springs that have a small number of active coils, if you have closed ends where some of the coils are inactive at the ends, those coils will become partially active. Some of those coils become partially active under loading. And so we do account for that, and it's based on research, and it should make your designs more accurate. So for example, if we have this set, if we have it turned on and we input 3 for active coils, ASD tells us that total coils will be 4.8, repeating 8. We also get a message, end coils partially active. Now if you have a spring that has 5 active coils, now you get the standard 2 inactive coils. So you still get that. But anything under 4 active coils, and your total coils will be reduced from the default. The next item we want to cover here is the user-defined SN data, and this will hold for other spring types as well, but we'll cover it here. User-defined SN data will impact the fatigue life calculations that are done on your spring design. By default, you do not get a particular cycle life calculation done. We do produce a modified Goodman diagram, and I'll go ahead and put in some data here so that we can see this in action. We'll load this between 13 and 26. So we get a complete design. Take a look at the fatigue strength diagram. Of course, the lines here are for 10 million, 1 million, and 100,000 cycles. And because our design point is well below the 10 million line, that means we have an expectation of more than 10 million cycles for this spring. And this is based on the data that is available from the SAE paper referenced in the SMI Handbook of Spring Design. It's the SAE HS 795 Spring Design paper. If we go ahead and click user-defined SN data now, we get a caution message indicating that user-defined fatigue data will be applied, and now we actually edit our table to indicate what we would like to use. And if we say that at 100,000 cycles, we believe there is 25% of the minimum tensile strength, and at 1 million cycles, there is 19% of minimum tensile strength, and for 10 million cycles, we only want to allow for 12% of the minimum tensile strength. And when we solve, our fatigue strength diagram has been updated, and the endpoints of these fatigue lines here correspond to the values in the table. So this value here is at the 12%. And 19, well, that corresponds to this value. And the 25%, that's right here. In modifying that, notice how our design stress point is now between the 1 million and 10 million cycle lines. We also see that an estimated cycle life value is now displayed here on the form. So you actually get a value there now. And that will appear whenever you have this box checked. If you don't check this box, then the estimated cycle life value will not show here. You'll only have the Goodman plot. The last topic we're going to cover in this session will be the minimum weight design. And I'm going to go ahead and restart. So we get a fresh form here. Minimum weight design does several things. It makes some assumptions. It pegs the percent of minimum tensile strength at solid to 45%. It also pegs the cycle life at 10 million cycles. So those assumptions are made. It also offers, as a suggestion, these 4 inputs. However, there are other combinations that will work, as we'll see. So just to run an example here, let's say that we have a coil with 1-inch diameter loaded from 7 pounds to 30 pounds, and at the maximum cycle load we deflect to 3/4 of an inch. Given that information, the software is able to solve the equations, and it shows us what the wire size should be. As I said before, you can work in any direction with this. So, for example, we could say, well, we need the wire diameter to be exactly 0.09, and we're going to remove the coil OD constraint. So now it back calculates and says, well, this is what your coil OD would be given a wire diameter of this. That concludes this session.